Hello and welcome to the session. Now let's start an interesting topic, JUnit, unit testing framework, and what are the offerings into it. We will see some theoretical session earlier, and then we will also do hands-on. We'll create a fresh project and we'll show you how it can be processed. So let's get started. So now before starting the actual JUnit, let's understand what is unit testing. So let's see some theoretical points here. So a unit is the smallest and logical testable element of any software or a software component. Makes sense because when we do testing from a QA perspective, we need to test a smallest or logical testable element. Unit testing is to test all smallest and logical testable element independently. So the word independently is important. Why? Because nowadays there are projects which are having complex structures. So every module or every individual item can be delivered or can be or has to be tested individually or independently. So that is what is unit testing. Now consider, we will also consider a simple e-commerce example, for example login module, but then same can be extended for search, checkout and payment. Um, Last thing is unit testing is really not testing each code level function, but testing individual logical functionality and data flow and etc. So now let us see from a developer's perspective. If the login module has to be designed, then let's say developer might need to interact with some other modules or other microservices, for example, for capture processing, for credential validation from some database and etc. But when it comes to QA as a part of unit testing, so normally what we do or normally what is expected uh, for as a unit testing is to provide a valid or invalid username, password, captcha combination. So so in overall we can say it as overall happy data path or unhappy data path testing. So a very simple and relatable example for unit testing. Now let us see what are the JUnit perspective, what are the items. So JUnit, Java unit testing framework, it is XUnit family of unit testing framework. So there are multiple languages, Java, Python, Ruby, etc. So every language has its own flavor of unit testing framework. So in Java we have JUnit unit testing framework. It allows to implement and run unit tests using Java programming. It provides annotations to identify test methods. So there are something called as annotations, and using which we can run individual test as a unit test. It provides test runner to run individual and group of tests. So we have a facility using test runner so that we can group the test cases, or we want to run it individually, we can also do that. It provides a test grouping facility, also called as uh, test suites. So we will see also hands-on on test suites. It provides parameter data passing mechanism. So for day-to-day test execution, for unit testing, or for any sort of testing, we need to pass a custom data to the tests, and accordingly a test will get executed. So that is called as parameter passings, and we have a lot of mechanisms in JUnit using which we can pass the parameters or data. Now it provides a fixture mechanism. A fixture is really useful to run a few common activity before and after particular test or set of test cases. So before and after is also a very good feature available in unit testing, and and JUnit provides that. Auto result aggregation mechanism. So um, it will automatically update the results itself for all the test cases, and when the execution is finished, you'll get a simple format of formatted test results, so it will automatically aggregate it. So as a developer of unit testing framework, we as such need not to do anything for reporting purpose as such. Now assertion mechanisms, if you want to terminate the test case for a certain reason, for a certain situation, we can also do that. So now let's create a, let's do a hands-on, and we'll create a sample project. Now we can create a sample project using IntelliJ or Eclipse, but the thing is, as we are using a JUnit framework, so we need to add external jar file dependencies so that we can run that test case or that particular project as a JUnit. So we'll create a project, we'll add the, so you can Google it. Where you can find this jar files in a payment repository or any other place. Just download it, put it in some folder, and we will create a project. Now I have these two files downloaded already in this folder. So what I've done is I've created a fresh folder where I will create a project. Inside that folder, I have created one more folder where inside this folder I've downloaded the jar file. So let me copy this folder path, and I will go to IntelliJ. I'll say new project, next, and that's it. So now I'm creating a project, very simple steps. Right now here, if you see, this folder is shown, but I need to actually import these libraries as a dependency. So what I'll do, I will go here and project structure and more libraries, and I'll add Java libraries and external jar, and I'll select this folder so that these two jar files will be automatically imported. Okay, now I'll just create a sample class, for example demo, and inside this demo class I will create a test method. So at the rate test, which is from a JUnit. So what is this test annotation or test parameters and all, that we will see also as a part of introduction. So let me create a method. I will say demo method, and for now inside this method I'm just putting a system out println, and I'll say JUnit. Okay, so this is a very simple project. We have just created a testng based project where we imported jar files as a project structure, as a dependency on this project, and we have created a method which will be annotated using test parameter or a test annotation, and how to run it. Now to run it using IntelliJ or using Eclipse, there are ready-made plugins which are available. So you need not to actually download any plugin, and so it is already by default in any of the latest IntelliJ or Eclipse. It will be already there. Plugin will be already installed. So right click and just run it. Okay, so it is doing some compilation and building, and that's it. So now you see this JUnit hello. So this is a very simple example. So we will see in detail what signifies and what are the importance everywhere. Okay, so we have created a class and we have used the test annotation. Now we have said multiple things here. So test, at the red test, and we have said annotation, and we have used a plugin. So let's understand these things in detail, which will be good for further understanding. So first let us see what is annotation, and then we will see what is JUnit annotation. So annotation. So it is little theoretical part. Annotation is a form of syntactic metadata or additional information that can be added to Java source code. So it is basically something additional data we are passing or additional information we are passing. We are adding that as a part of source code. A metadata, annotation, or tag can be added to a class or a method, right? So if we have seen in our uh, uh, object-oriented programming concepts, or if you have done extensive Java programming, you might have seen this kind of at the rate deprecated or at the rate suppress warning. So these are called as annotations, and that's why it is passing additional information to the Java source code. Now we have used at the rate test. So what is at the rate test annotation? So it tells JUnit that the public void method. So we have created a public void method here, public void method. It tells the JUnit that the public void method, for example, whatever method to which it is attached, can be run as a test case. So remember what is our ultimate goal here is to have a unit testing framework which will allow us to do unit test. So that is what uh, uh, to to which it is attached and can be run as a single test case or as a unit test case. Uh, to run the method, to run the method JUnit first constructs a fresh instance of the class, then invokes the annotated method. So now when we run this, what has happened is JUnit actually has created a fresh instance of this class and then called this method. Okay, once again, JUnit, when we use this at the rate test annotation, the JUnit itself has created an instance of this class internally. So in other words, um, we as a user, we as a automation developer need not to create an instance of this class. JUnit creates an instance internally and it will call whatever methods are here marked with at the rate test annotation. Okay, so to run the method JUnit, so what is this method? Method is basically one test case. So whatever method we'll be creating, that also we'll see in the subsequent session. So we can have multiple methods, and that method, uh, to run the method JUnit first constructs a fresh instance of the class and then invokes the annotated method. This is important. This can be an interview question and also uh, easy to explain in the interview. Now IntelliJ Eclipse comes up with this plugin to run JUnit test cases to be uh, as a ready-made plugin. Now some of the precautions. So at the rate test method should not be private or static, and this at the rate test methods should return void only. So let us see there is this limitation inherently. So first thing is, let's see this private and static. So what I will do, instead of public, I'll make it as private. Okay, so now it will compile, but when you run it, it will give you an exception that it will say private is not allowed. Okay, so it should be public. So it should be public. Okay, and it should not, it should return only void. So now let's say, uh, the other thing is it should not be static. So I'll make it as static and I'll run it. So it will give an exception, right? So this should not be static. So I'm removing the static part. Now it makes sense. Why? Because as we discussed, that when you run this class, it will basically run all the JUnit test cases here. And what happens is internally the object of this class will be created and these methods will be called. So obviously we want to return void because we are not using the return type anywhere, and we are able to call only public methods. Okay, so private methods should not be able to call. That is why these are the limitations. Okay, so now this is basically how to create a simple project and how to run it using test annotation. Point to remember here that there is no main method. So to run any other Java program, we must have a main method so that JVM picks up that main method and it will start execution. But that is not the case with JUnit because the main method functionality is not required. It is handled internally by JUnit. Okay, now let us see this parameter timeout now. Now, so I have this sample project here where there are a lot of classes and other examples. So let's see one by one. Now, for simplicity, let's go with this one first. Now, this is one class which is again, there's a JUnit test annotation here. Now, let us see this. So in this class, there is just one, for now, there is uh, one method here which is annotated with at the rate test annotation, and it is simply just printing some statement here, so which is very simple. Now let us see the timeout parameter. Yeah, this timeout parameter example. Now what is this timeout parameter example? And we will also see this expected. So what is this timeout parameter example? So what happens is, let's say now in your particular Java class, now there are multiple at the rate test annotated methods. Okay, now consider that you have written, let's say, 5 individual unit test cases. So this will be run in sequence, like you write scenario 1, scenario 2, scenario 3, and so on. So it will be executed in the sequence. But now what happens is, consider that because of some logical issue, uh, let's say a particular scenario is taking, let's say, 10 minutes for execution, or maybe some infinite time of execution. Now what will happen is, this particular unit test will take a lot of time to execute. That means that the other test will not be executed within a provided time, or for any other reason. Now that is what is the problem here, that we want that a particular unit test case, if you want it to have a kind of a cap, so that maximum time it should take, so that is what the timeout option. So if you say timeout 1500 millisecond, that means that this particular test method, it should not take more than 1500, that is 1500 millisecond. If it takes more than that, then it will throw an exception, the method will fail, and it will start executing the next method. Okay, so that is this timeout. So also on the other hand, if the test execution has happened within this 1500 millisecond, then no issues, it will be a smooth execution. So that is this timeout example. Now what is this expected parameter? So consider that you have this method, you have a method, and it is doing some operation, and it might throw an exception. Okay, it happens logical, there are logical mistakes or logical errors in the programming. So consider that now this is an array list, and I am, there is no data inside this array list, but I'm trying to access, let's say, the element with index 1. So because there is no data, so I cannot access any of the element, and this particular line of code will throw an exception. So what is that exception? It is called as index out of bound exception. So now for now, um, if you are running any particular test method, and if you expect that, okay, there is a known issue, or it might throw a known exception, then that is what is handled by expected. So your code throws an exception which is handled here using these expected parameters, then the test case will not fail. Okay, because you said that it is expecting this kind of exception. So if the exception has occurred, and if the exception matches here, then your test execution will not break, it will be pass. So these are the simple steps here. This is what we have seen already. Yeah, so now let us execute this. So how to execute this? What I'll say, right click and run. Okay, so now this is taking 1500 millisecond, and it has failed. So let us see scenario 1, 2, 3. Now scenario 1 is simple, scenario 1. Now if you see, this additional reporting has come up automatically here, which is auto result aggregation. That is what we have seen in the earlier discussion. So if you run your test using simple Java program, let's say you have main method, and you run different methods and all. uh, in that case, we don't see this additional aggregation here. So that is the advantage using JUnit, that we get a plugin, and then here we can see a lot of results and all. So that is a little fancy thing, but yeah, we can have multiple use cases for this. So this is my class here, and these are the individual tests. If you see, I can see individual test result also, or individual method results also. So this one, demo 1, scenario 1, okay, it is executed fine. Now demo 1, scenario 2. So this has failed. Obviously it has failed. Why? Because this loop is an infinite loop. So there is a timeout here. So after 1500 millisecond, it has thrown an exception. So what is the exception? It has test timeout exception. Test timeout exception. So obviously it will throw an exception here. And third thing is this expected one. So now this particular line will throw an exception, which is array, which is index out of bound exception. So that is what here. So this third test case, it will print this, it will throw an exception which is already uh, captured as an expected exception, and it will still pass. Okay, this test case will still pass. So test case number 3 has already passed, unit test case 3 has passed, and so on. Okay, so we have seen timeout parameter here, and we have seen the expected parameter here. Now let us see this example. So this is basically a real world example. So really, if you want to test it to test some functionality, so I've taken a sample example here. So I have this class called as bank account, and I have this method called as add bank account, and there are some three parameters I'm passing, and I'm doing some logic check here, that how can I compare the account ID, account name, and balance, and so on. So there is some logic here that the account ID should be within this range, and account name string should not be null, and opening balance should be obviously positive. So this is a functionality. So now I need to test this class or this functionality. So what I can do is I can come up with unit test cases to test this. So for every unit test case, basically happy path, unhappy path. So what I will do is I will pass some account name, account ID, and maybe opening balance, which is not in this range, and so on. So that is what I'm doing, individual functionality level testing. Now let us see here real world example. So now I have this method here which is annotated by test. So whenever I run this class, it will run as a JUnit test class. Now here what I'm doing, I'm just creating an object here, and I'm just calling that method. So I'm calling it twice here. If you see, I've called it twice. So in the first case, I'm passing account ID, account name, and opening balance. Opening balance is you see 400, that is a positive balance. And in the second case, if you see, I'm passing a negative balance. So obviously for negative balance, I will not be able to create an account. So if you see in this case, if the result is correct, if the result is true, then I will be able to open an account. And in this case, the result will be false. Why? Because the opening balance is negative. So it will throw an exception. Now this is the assertion mechanism in JUnit, so that you can stop the execution at a particular logical unwanted or undesired condition. So now let us run this. So what will happen now? So this is the real unit testing, wherein I have this test functionality available somewhere, and I need to test it using Java programming. So that is what it is doing using JUnit. So in this case, what will happen? First, it will create an account. So obviously, happy case will be true. So it will not assert, and it will print this. Now, in the unhappy case, what will happen is the amount is negative. So unhappy case will be false. That means it will assert. Okay, and it will print this line. So let's see. Right. So able to open bank account, case one. So case one is successful, and case 2 has failed. So unable to open the account for case 2. So that has failed. Now this is again a simple example. Right. Now let us proceed and understand the other annotations. So at the rate run with. So at the rate run with is a very common annotation we use in JUnit framework. So it specifies a group of many test cases as an aggregation. Now consider that you have multiple classes, individual classes, they have their own functionality or unit test cases. Now you want to run this set of classes in a separate way. So basically I don't want to run individual classes, I want to run everything combined. So how that can be done is using run with annotation. So it specifies a group of many test classes as an aggregation. When a class is annotated with run with this annotation, JUnit will invoke the class it references to and run the test in that class instead of the built-in runner. So that is what this run with is doing. Now to do this, we also need one more annotation called as suite, at the rate suite. So at the rate suite is a standard runner that allows you to manually build a suite containing tests from many classes. So now let us see with an example here. So if you see here, I have this package where I have demo 1, I have demo 2. So now I want to run these two individually, individual classes, individual JUnit classes in a third class. Okay, so how that can be done is, let's say uh, I want to run demo 1 and demo 2 in demo 100. So I want to combine this. Okay, I want to make them as a suite. So that is what is here. So run with I'm using. So run with something called as suite dot class, and I have to pass this parameter suite dot suite classes, and here I will pass whatever number of classes I want to run. So demo 01, demo 02, demo 03. So now what will happen when I run this particular class demo 100? This will actually run all the individual classes. So that is the advantage here, that we can control number of classes execution in this in another separate class. Okay, so running multiple JUnit annotated class. Right, so now let us run it. So this will basically run the demo 1 and demo 2. So what is there in demo 1? Let us see in demo 1. In demo 1, scenario 1 is there, and in demo 2 scenario 1. Right, so that is what is happening here. If you see demo 1, demo 1 scenario 1, demo 2 scenario 1, and so on. So that is the example of Runwith and suite dot class. Okay, now let us see this parameterized class. So we have discussed that we should have a mechanism to pass on parameters to test classes or test methods. So parameterized dot class annotation, it is used when we need to run entire class for multiple data set or passing different set of parameters. Now this is important. This will be useful when we will understand data driven framework, because we need to pass different parameters or set of parameters. Now let us see an example. And this time we will see a real example. Yeah, so first let us see this bank account example. Now here what is done is I'm using this parameterized. So I need to use something called as @runwith, and instead of suite I will be passing parameterize. So when I say parameterize, that means I will be making a separate mechanism to pass parameters. So let us see that mechanism. Right. So I have for this case, for simplicity, I have this bank account class, again the same logic here, and I have this demo class which will actually test the bank account class. Now what I'm doing, I'm creating a class here, and I'm creating a constructor here. So when I create a constructor, an object of this class will be created whenever @test will run. Right. So whenever @test will be run, this one, then an object will be created of this class, and that will be passed on these parameters. So this is the advantage, that we can pass a number of parameters, or basically parameterizing a class, so that we will take external input and continue the execution. Now uh, so for now I've taken it as a collection, as a return type. Need to return data as a collection, because we have a mechanism to pass set of data, right? So one set of data, one set of data, another set of data, or in other words, we can pass the parameter as a 2D array. Okay, 2D array of object of any type. So if you see this is an array, but this is an array of object. I can have an integer, I can have a string, I can again have an integer, and so on. So what I'm doing is I'm passing a 2D array of object type. Now this will be helpful when we see actual Selenium example, but anyway, for now I'm passing a 2D array where I'm passing a specific set of data which will be used here. So this is, as I said, this will be used for the creation of this bank account. Now technically what will happen is whenever I pass on this data will be passed to the object of this class. If you see, it is matching, so account ID, account name, and opening balance. So that is how, that is where I'm passing the data. Basically it will be passed to the object or to the constructor of this class. Now what actual test I'm doing, if you see here, so what test I'm doing, I'm actually creating an account here, and I'm using the account ID, account name, balance, and checking whether the, so I'm basically creating an account using this method, and I'm checking whether the account creation has been successful or not. So from where this object has come, it has come from here. And as I said, whenever the object, whenever @test will be invoked, that time this parameterized and the constructor will come into picture, and individual values those individual values will be assigned to these parameters. Okay, see, this is how the assignment is done. So these values will be passed as an argument here, and those will be assigned to this global parameters, okay, or the instance variables, right? So for every data set, this test method will run. Okay, so this is the way it is, that the number of data sets are there, the number of times this test method will be called. Okay, or for that matter, for below test method will run for every set of data passed to the parameterized annotation. Wherever this parameterized will be there in that class, all the tests will have this set of data, and they will be run this many number of times. So let us just run it and see the output. Okay, so there is a three set of data here. If you see three set of data, so that is why it has run three times. Okay, now this data itself, this is a correct data, this is a wrong data, and again this is a correct data. So that is why the second test case has failed, because of the, the amount, this opening balance amount is negative. Right, so that is what we will see in the test results here. So if you see this one, this is a correct account created. Second one, account creation has failed, not created, and third one is again account created. Now just to make you understand uh, this parameterize. So what happens is, as we have discussed, this data, right? This data will be passed to this constructor, and this constructor will be this object, or basically the object of this class will be passed for every test method. So if you see, this is one dummy method, or just method does nothing, just a print statement. Now what will happen is, because there are tests methods which are defined here, and there is a parameterized data which will be passed to the every method, right? So this data will be passed to this method and this method, irrespective of the second method needs it or not, it will be passed there. So the point here is, these two methods will be run three times. Okay, if you see, this method is not using the data, but it will anyway be run three times. So let's just run it. Right, so if you see this one, nothing to do, it is printing nothing to do, here also nothing to do, and here also nothing to do, right? So the point here is, for every test method the data is available, and the every test method will be run the number of times, number of data arrays are here, number of entries are here, number of set of data are here. Now in order to understand this in a better way, let's see an actual Selenium example, which is bit relevant. So again, I'm using this parameterized class, and I have this class name demo 300. There I have used some global or instance variable, like to which URL I want to navigate, and what is the XPath of the element on which, let's say, I want to click or do some operation. Now again, I'm creating a constructor here, and I'm passing using those parameters which are passed here, and I will assign it to the instance variable. Now again, this parameterize annotation, parameterize annotated method, wherein I will be passing three set of data. So obviously it's a 2D object here. If you see 2D object, 2D array of object, and I am passing URL and element. Okay, URL and element, URL and element. So that is what is here. I am passing every URL and element XPath so that I can do some operation. So obviously now if you see, this data in turn will be available to this every test method here. And here what I'm doing is simple uh, Selenium code where I'm invoking a browser and doing some operation. So I have this new Chrome driver, right? And I will be going to this particular URL, right? So from where this URL is coming, it is coming from the global variable or instance variable, but actually it is coming from this parameterized annotation, and it is coming from the constructor. Okay, so I got the URL. I will navigate to that URL here, and then I will click on that element. Okay, so one of the cases there where uh, the actual individual test will fail, but that is okay. We will see that. Okay, so out of three test cases, first test case is started, and it will go to some website, web page, and let's say it will click on that element. Okay, second case. Okay, and third case. Right, so three test cases were run, all the test cases were passed, and there is some output here. But now you can see individual test has gone to different URL, and it has clicked on the different element. So that is what is here happening here. So every test method here, every test method will be run number of times the data array whatever is passed here. So for basic session, for basic JUnit understanding, this is sufficient. Now let us see other annotation and other examples in the next sessions. Thank you.